Uh, Good morning. Uh, right. I think some students will be late because due to there's a huge traffic there, but we'll continue the class. Right. Right. How did we start the things there? We start saying about physical quantities. Please don't write anything. I no need to write. Right. The most important thing is listening than writing. So listen to me. How did we start the things there? Saying about physical quantities. Let's recall the memory. Let's revise the things that we have discussed so far until the students come, right? I don't think that it will be easy for them to come because of the huge traffic, right? And at the same time, you should remember these things. What is a physical quantity? If you can measure something directly or indirectly, it's a physical quantity. What it means in simple words, physical quantities are the measurable things. What are the physical quantities there? Measurable things. What are the best examples there? Mass, then length, then time, temperature. You can measure these things, right? Right? So if you can measure something directly or indirectly, it is said to be a physical quantity. Then we have learned something so-called fundamental physical quantities. Fundamental. The meaning of fundamental, I explained by using as I remember, I explained it by using two examples. First example that I have used is acceleration. Please don't write anything. Acceleration. What is acceleration, dear? Increase in velocity divided by time taken. Then I ask what the velocity is. What is velocity, dear? Velocity is displacement divided by time. Displacement divided by time taken. After that, I ask what the displacement is. What the displacement is. Then we said displacement is the shortest distance. Displacement is the shortest distance. Shortest distance. Shortest distance. After that, I asked what the distance is. Then what is distance, dear? Distance is the length of the path. Length of a path or length of the selected path. It means I use this example. For example, if you want to travel from Kandy to Gampola, can we travel along a straight line road there? No. There are no straight line road from Kandy to Gampola. We have to follow some curved path like this. So this is the road from Kandy to Gampola. Then what is distance from Kandy to Gampola? It is the length of the road. What is the distance, dear? It is the length of the road. For example, if we say Kandy to Gampola, distance is 40 kilometer. 40 kilometer is the length of this road. If somebody measures the length of this road, it will be 40 kilometer. Then we say distance from Kandy to Gampola is 40 kilometer. Got it? Then I ask what the length is. When someone asks Acceleration. What is acceleration? We have an answer. What is the answer for acceleration there? Velocity over time. If someone asks what the velocity, we have an answer. What is it there? Displacement over time. If somebody asks what is displacement, we have an answer, shortest distance. Then if somebody asks what the distance, what's the answer here? The length of the path we select. But once it is asked length, do we have an answer? No. Then we say length is a fundamental. So length is something we can measure. As length can be measured, it is a physical quantity. But we can't define what the length is. Please come to this side, dear. Dear, please come to this side. This side. If somebody asks what the length is, we don't have an answer. That's one way of answering, explaining fundamental. But the best way to explain fundamental is this. I think I have given that example. Best way to explain fundamental using chemistry. What is an atom, dear? What is an atom? An atom is a combination of three particles. What are three particles, dear? Neutrons, protons, and electrons. Neutrons, protons, and electrons. Then if somebody asks, what are the things inside neutrons? Quarks. Quarks. If somebody asks, what are the things inside protons? Quarks. So it means neutrons can be divided into three quarks. How many quarks, dear? Three. What are three quarks, dear? Up quark, down quark, and down quark. In A-level MCQs asked, what is the quark combination of a neutron? What is the quark combination of neutrons, dear? Two down quarks and one up quark. What about proton? If you consider proton, there are two up quarks and one down quark. So examiner can ask, right. Look at board, dear. So what's the quark combination there? What's the quark combination of a proton? There are two up quarks and one down quark. Got it? What's the quark combination of neutrons, dear? Two down quarks and one up quark. Got it? Right. Then, have you heard that charge of a proton is +1? How this +1 is created? How the +1 is created? Protons. Charges are in the quarks. Where are the charges there? Charges are in the quarks. For example, let's say charge of a up quark is 2/3. Charge of an up quark 2/3. Charge of a down quark -1/3. So then what is the total charge of a proton there? Proton is made of three quarks. What are three quarks, dear? Two up quarks and one down quarks. Right? Then what's the charge of up quark? Plus 2. Charge of up quark plus 2. Then what's the total charge, dear? Total charge. Total charge is equal to 2 over 3 plus 2 over 3 minus 1 over 3. Now what is the common denominator? Common denominator is 3. Then we get 2 plus 2 minus 1. What is 2 plus 2, dear? 4. 4 minus 1, 3. 3 over 3 is 1. Come to this side, dear. So what's the charge of a proton, dear? Plus 1. Got it? A proton is made of three quarks. What are the three quarks, dear? Two up quarks and one down quark. What's the charge of an up quark, dear? What is the charge of an up quark? The charge of an up quark is 2 over 3 plus 2 over 3. What is the charge of a down quark? Minus 1 over 3. You have to do all these things at the final lesson of the syllabus, matter and radiation. Shall we try to, don't write anything. Shall we try to find the charge of a neutron here? Only one up quark, 2 over 3. How many down quarks? 3 down quarks. Minus 1 over 3, minus 1 over 3. Right? The denominator is 3. Right? So what's this, dear? 2 minus 1 minus 1. Common denominator is 3. Now what will happen, dear? 2 minus 1 is 1. 1 minus 1, 0. 0 divided by anything? Who has learned these things in O levels? You can learn all these things in advanced level. You can learn all these things only if you follow math stream and go to university. If you follow biological science streams, you can never learn these things in university. So therefore, it's very important to select a teacher who has studied physical science subjects, maths, physics, chemistry, in A levels and university level. Otherwise, they don't know these things. Right? For example, if you don't believe me, ask what will happen. The quarks are bonded together. What will happen if we stretch two quarks until the bond is broken? Ask and tell me what will happen. Open challenge. If your teacher has not studied physical science subjects in A level, in university level, they can't learn quarks. This is a major section in physics. What's the final lesson there? Matter and radiation. Got it? So this is how the charge of a neutron 0. This is how the charge of a proton is 1. Then let's come back to this case. Can we divide quarks any further? No. As we can't divide quarks any further, quarks said to be fundamental particles. Got it, dear? I think that is the, not I think. That's the best definition for fundamentals. What's the best definition for fundamentals, dear? It is something you cannot divide any further. What is the fundamental, dear? Everybody speak loudly. It is something that cannot be divided any further. One of the best examples for fundamentals, quarks. You can't divide quarks any further. Right. Okay, here? Clear? Right. So the best way to explain fundamentals, it is something you cannot divide. What's the simplest definition of fundamentals? Fundamental physical quantities are the quantities that cannot be defined by other physical quantities. You think something is better than nothing. But what's the best way to explain fundamentals? It is something that you cannot be divided any further. They are the building blocks of everything. Got it? Right. Electrons are said to be, electron is also fundamental particles. Still, we are not able to divide electrons. Electrons is a member of lepton family. What family? So all these things you can learn only if you learn physical science subjects in A level, maths, physics, chemistry. When you go to university, if you go do an engineering degree, or a physical science degree, then only you can learn. Otherwise, you don't know these things. Learning these things in a university under a professor and asking about these things from a friend are two different things. Got it? Right. Are you all okay here? Fundamentals are the things that cannot be divided any further. Or fundamental is something that cannot be divided, cannot be defined by other physical quantities. Got it, dear? So, discuss. There are 7 fundamental physical quantities. What are the 7 fundamental physical quantities, dear? Mass, length, time, electric current, amount of substance, luminous intensity. Right? To measure these 7 fundamental physical quantities, there are 7 units. What are the 7 units of fundamental physical quantities there? Mass is measured by kilogram. Length is measured by meter. Time is measured by second. Temperature is measured by Kelvin. Kelvin is the name of a scientist. Therefore, we should use capital K. In the exam, they will give the unit of Kelvin as simple K. And they will ask, examiners will ask you to select the correct answer. What is the correct answer here? Unit of temperature is simple K or capital K? Capital K. So, do there are such easy questions in A-levels? Yes, yes. All the questions are not difficult. All the questions are not difficult. Most of the questions are easy. Electric current is measured by ampere. Ampere is the name of a scientist, therefore capital A. Amount of substance, mole. Mole කියලා මිනිහෙක් විතර තියෙනවද? නැහැ. So amount of substance is mole. Mole is not a name of a man, therefore simple MOL. Luminous intensity, candela. I forgot to tell you about luminous intensity. This is a very important fact. Who are the physical science students here? Who are the students learning maths? Now, so when you become engineers, let's say let's say you are an electrical engineer, for example, right? This is a factory. Maybe a garment factory, maybe a mobile phone manufacturing factory, something like this. Then one of the main job is you check the luminous intensity. You have a meter, you check. You go to places and check. Why? There should be a certain luminous intensity for the humans to work comfortably. Who has heard it there? So actually, when this classroom is designed, we should try to give the most comfortable luminous intensity for the human ears for each and every desk. That value should not be exceeded. That value should not be lowered. There's a certain level of luminous intensity. So engineers should check and give the exact luminous intensity for each and every disk. or each and every place. For example, if you assembling a mobile phone, if you are the quality check, right? The correct amount of light should be there. It should not be exceeded. It should not be lowered, right? What's the SI unit of luminous intensity here? Candela. Is candela a name of a man? No, no, no. Therefore, simple C, simple D. These units are said to be international units. Why is that? Why are they called international units, dear? Because majority of the countries in the world use them. These are called SI units. Why? International units. Why? Majority of the countries use these units. Clear? Right. But when I was a student, I don't know whether you feel it like that. When I was a student, when it is said international units, I thought, good units. International one, foreign one, good one. Is there anybody who feels like that? When somebody coming from a foreign country, Suddik. International, good units. So luckily you don't feel in that way. But when I was a student, I thought, I'm talking the very first day of the class, when the teacher said, international, not local. But later I understood that something international means it's used by majority of the countries. Are there any other countries that don't, which are not using international units? Yes, yes. Best example, America. We ask 1 liter of petrol, they 1 gallon. We say 1 kilometer, they say 1 mile. Right? We say centimeters. Length of a pencil is 10 centimeters. They say 6 inches. So what is the upset with this? There was a huge problem. I don't remember the name of the spacecraft. It was designed in Europe. Right? So all the calculations were done in SI units, centimeters, meters, kilograms. Launched in America. Now what are the units there? Inches, miles, pounds, right? Adi pound rata. Then what will happen? The rocket was broken. There was a huge explosion. It was destroyed. You can find these things in details because design process was used. In the design process, they used SI units, but it was used in America with the inches, pounds, like that. Got it there? So therefore, it's better to have the same system of units everywhere in the world. But American people think they are different than all the other people. They are the masters. So they use a different system of units. But most of the other countries, they use these units. So they are called international units. Got it there? Right. Then we have said something so-called derived physical units. What are the derived physical units there? They are the derived physical quantities. They are the physical quantities obtained by using other physical quantities. What's the first example that I have given for derived physical quantities there? Acceleration, sorry, velocity. What is velocity here? Please don't write anything, right? Velocity equals displacement over time taken. Displacement over time taken. Displacement is a length. Displacement is the shortest distance. Distance is the length of a path. Therefore, displacement is a length. So what is the unit of a length? Meter. Time measured by seconds. Got it? So what is the SI unit of? International unit of. International system of units. If it is international system of units, it should be written as IS. IS. but we use SI. Why is that? Because the process of developing, the introducing, it means, what's it called? It means international systems, an international system for the units to develop it, to introduce it. Majority of the things were done by French scientists, right? Actually, this conference was take place in Paris. As many, actually, they are the people. France is the country. French, they had done a lot of things to introduce a system of units for all the countries in the world. Therefore, we use the French form. What's the English form? IS, International System. French form, or system is something. They say system first, international next. So what is the SI? I give printed note about history of SI units. Some people are interested in history than the present, right? So they can read. So what is the SI unit of? What is the SI unit of velocity? Displacement divided by time. Displacement measured by meter. Time is measured by seconds. Meter divided by second. Meter per second. Got it? Please don't write anything. Listen to me. Why am I asking you to not to write? Because our students are expert in writing and they are very weak in understanding the things. What's the problem with the students? Nice handwriting, beautiful books, beautiful notes, but the memory is very ugly. They can't remember anything. So please don't write. Listen to me. What am I trying to do here? I'm trying to overcome the biggest problem. මොකද්ද ලොකු මේක? ලියනවා ලිවිල්ලක් ඔගේ අම්මේ ලස්සනේ බෑ නෝට්. මුකුත් මතක නැහැ. So how to overcome the problem, dear? First, listen well. If you want to remember something well, listen to it well. Sunata Dareta. Who has heard it? Oh, it's not a joke. You talk to your grandparents and ask, right? You ask grandma, our physics sir told Sunata Dareta, what does it mean? Right? Okay, tell me next week, right? So, velocity equals displacement over time. Displacement measured by meter, time measured by seconds. Meter over second is the unit of velocity, right? Then what is the second example? Second example, acceleration. What is acceleration? Acceleration is equal velocity divided by time. What is the unit of velocity here? Meter per second. What's the unit of time? Seconds. So, therefore, what is the SI unit of acceleration? Acceleration is meter per second divided by seconds. This S comes up, then you get ms minus 1 into s minus 1. Then m s minus 1 into s minus 1, s minus 2. S minus 2, ms minus 2. So what is the SI unit of acceleration? Ms minus 2. Then the next one is force. According to Newton's second law of motion, what is force, dear? Force is F equals ma. So force equals mass into acceleration. Mass into acceleration. Mass is measured by kilogram. Acceleration is measured by ms minus 2. Therefore, what is the SI unit of force, dear? SI unit of force is kg ms minus 2. But what's the unit that you have heard? Newton. So other scientists had decided to give some respect as a memorial thing, as an honorable thing. Other scientists name 1 kg ms minus 2 is equal to 1 Newton. Something to respect Newton as a memorial thing, as an honorable thing. SI unit of force was named as Newton. 1 Newton is equal to 1 kg ms minus 2. What's the next example, dear? We have discussed some examples. Please don't write anything. The other example, dear. The other example is, right? Pressure. What is pressure, dear? Pressure equals force over area. Force is measured by Newton, area is measured by square meter. Everybody knows it. So then what is the unit of pressure here? Newton divided by square meter, it means Newton per square meter. Right? But what is the unit that you have heard for pressure? Pascal. What's the unit there? Pascal. How Pascal came into this case? Same process. Other scientists wanted to give some respect. As a memorial thing, as an honorable thing, the scientists had named the SI unit of pressure as Pascal. So this is how Pascal came into this process. Okay, dear? So one day, let's say you find something for physics, or you do something for the development of science. You are doing a great job for the developing science. Your name is Sriyalata. Then there will be a unit called Sriyalata. You are not patriots. You laughed. Isn't it good? මන් තව අවුරුදු 10කින් විතර මැරි කරලා ළමයෙක් හදලා දානවා එකක් නමක් Sriyalata here. Isn't it good, boys? Upset වගේ නේ. Lamai, please overcome that problem. Please overcome that problem. Our country, our culture, our names. During this Iftar festival, I met Maulavi. He asked, "What are you doing?" I said, "I am protecting the culture." He asked, "How?" I said, "I'm a English medium physics teacher. I maintain our cultural values in my class." Even monks were invited, priests were invited. What's the most important thing? Our name should be more valuable for us. Our things are valuable for us. Even the language of instruction is English. Our culture is Sri Lankans. It's important, right? Let's come back to this, dear. So what is this, dear? So what am I doing? Even though I'm teaching in English medium, I'm protecting the culture. We maintain a good culture in our classes, right? Shall we continue? Shall we write another example? Right. How many pages have we written so far, boys? Yeah, please. How many sides? How many sides? 1, 2, 3, 4. 4 sides. It means 2 pages or 4 sides. How many examples have we discussed? 4. 6. Are you sure that I have discussed 6? Only 5, right? Anything good. මේකට තරහ වෙන්න එපා. දැන් ඔය 2025 ළමයි එහෙම ටිකක් තරහින් ඉන්නවා. බෝයිස් කියලා කියවෙන්නේ මම ඉගෙන ගත්තේ බෝයිස් ස්කූල් එක. ඉතින් මට ගර්ල්ස් කියලා කියවෙයිද කියලා මම වන්දේ. හරිද? බෝයිස් කියලා කියවෙන්නේ මේ කොල්ලන්ට වැඩි කැමැත්ත නෙමෙයි. ඔගොල්ලෝ වැරදිට තේරුම් ගන්න මට මැසේජ් ගන්න එපා. මොකක්ද මේ බෝයිස් කියන එකේ තේරුම? ඉගෙන ගත්ත ඉස්කෝලේ බෝයිස් එක. ඉතින් එතකොට ඒක බෝයිස් කියලා කියවෙනවා. ඉතින් මම මොකද කරන්නේ කියන්නකෝ. හරිද? තරහින් එපා. ඉතින් පුරුද්ද. ජම්මේට වඩා මොකක් ලොකුයිද? පුරුද්ද ලොකුයි. හරි. Right. We are discussing about derived physical quantities. We are discussing about derived physical quantities. Lamai, under derived physical quantities, that's a very important thing. We are just finding units. That's okay. But there is something so-called fundamental units of a derived physical quantity. Today's lesson is that. What's the most important thing here? Fundamental units of derived physical quantities, right? Before that, let me explain a few more examples for the derived physical quantities. After that, I'll go to how to find fundamental units, right? Now you don't have any idea about it, but after discussing a few examples, I'll go for it. Example number 6. What is area, dear? Area of a rectangle, area of a rectangle is measured by, calculated by length into width. Length is measured by meter. Width is measured by meter. Talk to me, dear. Length is measured by meter. Width is measured by meter. Therefore, the international unit of area, SI unit of area is meter into meter. Double meter. Meter into meter, square meter. Write it, dear. We'll start with simple things, dear. Now, all the things start with very simple things. Am I right? You say, hello, hi, good morning. Do you use WhatsApp? May I know your WhatsApp number? And a huge screaming, painful sound in the labor room in the hospital. Understood? Wow. But how it started? How it started? Hello, hi, good morning. Look familiar, right? Do you use WhatsApp? I have your number, WhatsApp number. When I have something difficult points in class, I may be able to discuss with you, right? Let's learn together. Group work is great. Group education is good, right? But what's the end? The huge, painful screaming sound coming out from a labor room in a hospital. Starting with very few, very simple things, nice things, but ending so painful. Good. For more details, please talk to Sampath sir. He's expert. Please talk to him. In physics question about ultrasound waves, ultrasound imaging, there was a part of the question, I don't remember the year, 2020 or 23, something like that. There was a word called fetus. So ultrasound imaging is used to find the length of the fetus. What is fetus, dear? What is fetus? Wait. Yes? How did it done? What is fetus, dear? Starting section of a child, actually baby, but smallest part. Embryo, fetus like that. So I thought like that. සම්පස්සගේ ස්ටුඩන්ට් කෙනෙක් කියනවා ගොඩක් ලකුණු ගන්නවා දිස්ත්‍රික් රෑන්ක් එකක් මේ පාර ගහනවා දෙයන්ගේ පිටයි ළමයා හොඳයි so fetus කියන්නේ නමක් නෙමෙයි ඇඟට දෙන කෑල්ලක් නෙමෙයි බබිකුට කියලා ලස්සනට explain කරා sir embryo fetus ඔන්නම after this much of days after this much of weeks කියලා ලස්සනට සම්පස්සගේ මම හිතන්නේ ස්ථිරව මෙඩිසින් යන ළමයි සහ රෑන්ක් එකක් සහිත ළමයි so happy with her so that's good thing right example number 7 volume lucky 7 volume what's the volume of a box here length into කියන්න width into height ලියමු බබ්බු ටික length into width into height length into width into height length is measured by meter, width is measured by meter, height is measured by meter. So therefore, what is the SI unit of length? What is the SI unit of length? What's it there? Meter into meter into meter. Meter into meter into meter means M. How many M's? 1, 2, 3. Therefore, M to power 3. We don't say M to power 3. We say cubic meter. We don't say M to power 3. We say cubic meter. Okay? Write them all. SI unit of length. SI unit of volume. SI unit of volume. Density. 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 O-level science. Mass divided by volume. Right. Density equals mass over volume. Mass is measured by kilogram. Volume is measured by cubic meter. Very good. Right? So therefore, what is the SI unit of density? Mass or volume. Mass is measured by kilogram. Volume is measured by cubic meter. Kilogram per cubic meter. Kilogram per cubic meter. Got it? Number 9. So, singer, very famous singer saying work done. Done නැද්ද? මොකද දන්නේ නැහැ මේ ළමයි. Work done කියලා හිටියා. WD අමරදේව. What is work done here? Work done is force into displacement. Wait. Force is measured by Newton. Displacement is measured by meter. Therefore, international unit of, therefore, the SI unit of WD, work done, equals Newton. Force into displacement, Newton into meter, Newton meter. What is the SI unit of work done here? Newton meter. But you must have another work done. What is it there? Yeah, right. Star point and right. මෙයාට කවුදනේ මෙයා? Please write as a star point and right as a all things that we have written today 6, 7, 8, 9. We have written only these things today. Okay dear? අපි අද ගොඩාක් ලොකු ට්‍රැෆික් එකක් තිබ්බ ළමයි ඇත්තටම ළමයිට එන්න බැරි තරම් විශාල ට්‍රැෆික් එකක්. මම දැන් තවත් ළමයි අතන හිර වෙලා ඉන්නවා කරන්න දෙයක් නැහැ. ඉතින් ඒගොල්ලන්ට බයෝ ක්ලාස් එකට තමයි යන්න වෙන්නේ මෙහෙට එන වෙලාවේ හැටියට. ෆිසික්ස් එක ඉවරලා තියෙයි. ඒගොල්ලන්ට මොකක් හරි මම වැඩපිළිවෙලක් හදන්නම්. අර හරිය ඉඳලම කිලෝමීටර් ගාණක් දිග ලොකු ට්‍රැෆික් එකක් තියෙනවා. හරි. මේ ටික විතරයි දරුවා අපි ලිව්වේ. හරි. Star point and right as a memorial thing, as a memorial thing, the SI unit of work done, the SI unit of work done, the SI unit of work done is named as joule. As a memorial thing, the SI unit of work done is named as joule. Is named as joule. So please write, everybody please write 1 Newton meter equals 1 joule. Got it? Right. Right. Lamai. In the examination, first question is, what is the SI unit of work done? What is the SI unit of density? What is the SI unit of area? That kind of things. So we learn like this. Ne? The question should be very easy. Ne? Am I right there? What is the SI unit of work done? Newton meter or joule. But examiner gives you a different answer. What is the answer that the examiner can give you? That's what I'm going to teach you next. I'll give you one more example after the 10th example. Examiner's answer for work done is not Newton meter, not joule. Why? Students know Newton meter and joule. Examiner wants you to fail the exam. Then he is very happy. Oh. Then he gives another answer. Got it, dear? Right. Number 10. Let's write it like this. Number 10. Universal gravitation constant. Universal gravitation constant. Within brackets, capital G, underline it. Universal gravitation constant. Within brackets, capital G, underline it. Who has heard universal gravitation constant in O levels? Right. Under that, please write what is number 10, but we have written it as a subheading like that. Under that, please write there is an attraction force. Please write, Babu Digalian. There is an attraction force between any two masses in the universe. There is an attraction force between any two masses in the universe. There is an attraction force between any two masses in the universe. That attraction force is known as, there is an attraction force between any two masses in the universe. That attraction force is known as gravitation attraction force. Gravitation attraction force. There is an attraction force between any two masses in the universe. Between any two masses in the universe. That attraction force is known as gravitation attraction force. Gravity. Same line, same point. According to Newton's law of gravity, same line, same point. According to Newton's law of gravity, according to Newton's law of gravity, comma, the gravitation attraction force, can be found by the following equation. According to Newton's law of gravity, comma, the gravitation attraction force can be found by the following equation. Look at board. Let's say there are two masses in the universe. The mass of the first object is simple m1 kilogram. Mass of the second object is simple m2 kilogram. Then Newton had found that the two masses are attracted to each other. The two masses are attracted to each other by a force. Newton named that force as gravity or gravitation attraction force. Whenever there are two masses or more than two masses, they are attracted to each other. Right? The attraction force is named as gravitation attraction force. Gravitation attraction force between any two masses in the universe can be found by Newton's law of gravity. We learn it as the fifth lesson of the syllabus. F equals G m1 m2 over r square. This capital G is known as universal gravitation constant. Wait, then what is R? R is the distance between the masses. Draw the figure, write the equation. capital G for, yeah, universal gravitation constant. Why didn't he put capital N here? Newton N දාන්න ඕන. G for Grace වෙන්නේ girlfriend's name. No, I guess this is my guessing because as I know, Newton was grown up by his grandmother. So maybe to say granny, maybe I don't know, but I guess. Uh, shall we try to find the unit of? Uh, no, no, no. Can you please rewrite this equation? Wait, wait. පොඩි වැඩක් බලමු. පොඩි වැඩක් බලමු. ඉගෙන ගන්න කාලේ තියෙනවා. There's a lot of time. I want to check who you are. Let's do a simple thing. F equals G M1 M2 R square. Subject capital G. Take a photo and send to my WhatsApp. Write this equation again. Subject capital G. Online people take a photo and send to my WhatsApp. Note 719212026. Other until online people send me what the subjecting of capital G. Let me check my physical students. most of you have subjected capital G successfully. But look at board here. Look at board. Look at board. Normally, look at board, please, please, please. Normally, I write the equation in the other way without writing F equals G M1 M2 R square. Without writing F equals G M1 M2 over R square, I'll write like G M1 M2 R square equals F G M1 M2 square over G M1 M2 over R square equals F. Then R square go to this side, M1, M2 go to the other side. Then what will happen here? G equals denominator R square goes to the numerator. Numerator M1, M2 go to the denominator. Division becomes multiplication. Multiplication becomes division when the terms are taken to the other side. Am I right? Then in addition, we have capital F. Unit of F, Newton. Unit of R, meter, square, meter square. Unit of R is meter, but this is R square. Therefore, this should be meter square. M1 is measured by kilogram. M2 is measured by kilogram. So whatever the way you have subjected capital G, sometimes your terms may be at, sometimes these terms may be at left-hand side. Please mark the units as Newton, meter square, kilogram, kilogram. Everybody please mark. Whatever the way you have subjected capital G, mark the units of M1, M2, F, and R square. Mark them there, everybody. So what should be the unit of capital G? The international system of units of capital G. What's it there? What's it? Square meter Newton. Square meter Newton divided by kilogram into kilogram. Kilogram into kilogram. Kg into kg. Without writing, stop writing. Please, everybody, please. Here. Hello. Hi. Stop writing. Look at board. Without writing square meter Newton, let's write Newton square meter. Newton square meter. Kilogram into kilogram, kg into kg, kg square. Kg square comes up with a minus sign, then you get Newton square meter. Kg square comes up with a minus sign, kg minus 2. So what's the unit here? Newton square meter per square kilogram. Who got this answer? But in the exam, they ask what is the unit of universal gravitation constant. This is the unit we know, but examiner gives another unit. That's what we are going to learn now. First of all, complete this, dear. Complete this. Here, right. Examiner asked the question, what is the SI unit of universal gravitation? Constant. What's the answer we know? Newton square meter per square kilogram. But examiner gives you a different unit. That unit is known as fundamental unit of capital G. This is said unit with derived units. But what is the unit given in the exam? Fundamental unit. To learn about fundamental units, first we have to learn something so-called dimensions. We have to learn something so-called dimensions. Or you can say dimensions. Dimensions or dimensions. Please write your heading as dimensions. So dimensions, dear. Dimensions, dear. Eh? Don't talk, friends. What are the dimensions, dear? Look at board. Look at board. For example, don't write. Please don't write. Listen to me. For an example, let's say the dimension of mass, don't write, is capital M. The dimension of length, simple M. The dimension of time, this is capital, dimension of length, capital L, mistake. Dimension of time, capital T. Then what are dimensions? The first way of arguing, according to this, dimension of mass, capital M, dimension of length, capital L, dimension of time, capital T. According to this, you can argue that dimensions are English letters. Am I right, dear? Then what are English letters, dear? English letters are some kind of symbols. According to the three things that we have written, we can argue that dimensions are English letters. But what English letters, dear? English letters are some kind of symbols. Am I right, dear? MLTR symbols. Therefore, dimensions are symbols. And what do they do? What do they do? Eh? What do they do? They represent mass, length, time. What mass, length, time, dear? Physical quantities. So dimensions are some kind of symbols. They represent physical quantities. Again, the dimension of mass is capital M. The dimension of length is capital L. The dimension of time is capital T. MLT are English letters. English letters are some kind of symbols. These symbols represent physical quantities. Therefore, dimensions are some symbols used to represent physical quantities. Got it, dear? Write the heading as dimensions. Under that, please write dimensions are some symbols. Dimensions are some symbols, comma, used to represent physical quantities. Dimensions are symbols. Dimensions are symbols used to represent physical quantities. Dimensions are symbols used to represent physical quantities. Dimensions are symbols used to represent physical quantities. Then please write examples. Examples, please write them. Write exactly like this. The dimension of mass, capital M, the dimension of length, capital L, the dimension of time, capital T. So what's our target? How to find the fundamental units. What is our target, dear? How to find the fundamental units which are asked in the exam. Universal gravitation constant in the equation R square is there. In this equation, we cannot write F equals G M1 M2 over R. It should be R square. Check. Okay, dear. Distance between the masses R. But to find the force between the masses, we should use square. Whose law is this here? Newton's law of gravity. Newton has given this equation. It should be not R but R square. Okay, yeah? If we use R, we will get a wrong answer for the force. Uh, another example, look at board. What about the dimension of temperature? The dimension of temperature or thermodynamic temperature. The dimension of temperature is Greek letter theta. Greek letters are also symbols. The dimension of temperature is theta. Greek letters are also symbols. Write it. Shall I write one more? What about the dimension of electric current? The dimension of electric current is capital I. But you should know only the first three things in the A-level examination. Lamai, I have given you the equation of capital G of capital A. Did I teach Newton's law of gravity here? No. It's just one complete lesson. Gravitation field is a one complete lesson. Did I teach gravitation field? Or did I teach Newton's law of gravity? No, I have just given you the equation. Please wait few months until I teach this equation. Did I teach the equation? No, I just mentioned the equation. Teaching an equation and mention an equation are two different things. I just mentioned it. I just said there is an equation like this. Did I teach it? Don't misunderstand. I didn't teach it. I'll teach it. Please wait few months. The only thing I wanted to say that there is something so-called gravity. This is the equation to find it. There's a constant in the gravity equation. That constant is G. Its unit is Newton square meter per square kilogram. Did I teach it? No, I didn't. Right. Now look at board. Now we have a problem. What are we going to do? We are going to find the fundamental units. To find the fundamental units, what is the method we are using? Dimensions. What are dimensions? They are some kind of symbols used to represent physical quantities. Why do we want them? The first thing is to find the fundamental units. Why do we want to find fundamental units? Because they are asked in the exam. Right. The problem is the dimension of it will be difficult to write dimension of. Therefore, we used a method to say dimension of. For example, if I want to say dimension of mass, I should write mass inside square brackets. What's the meaning of this, dear? Dimensions of mass. To say dimension of length, we should write length inside square brackets. It's a method to represent, right? So then short and sweet, we can save the time. How to say dimensions of time? Write time inside square brackets. Got it? Star point and write. The following notation is used. The following notation is used to say dimensions of. The following notation is used to say dimensions of. Dimensions of. The following notation is used to say dimensions of. To say dimensions of. Right? Please write dimensions of mass capital M, dimensions of length capital L, dimensions of time capital T. Please write them there. Only these three things are used in the A level. If you learn all the other dimensions, you are wasting your time. Right? I have seen that some teachers had discussed 200 questions, 100 questions for units and dimensions. So the teachers are stupid. They are wasting the time. This is just a one MCQ, right? For a one MCQ lesson, if you are doing 100 questions, your teacher is stupid and you are mad. We should not waste the time. Because there are many other good lessons, many other important lessons. For those lessons, we should save the time. Got it? Now, please write the next subheading. That's the most important thing. We are going to find fundamental units of physical quantities, and I'm going to use dimensions for it. Please write the next subheading. The dimensions of derived physical quantities. The dimensions of derived physical quantities. The dimensions of derived physical quantities. Derived physical quantities. Underline it. Right? Look at both. First one, if I write velocity, look at board. If I write velocity inside square brackets, what does it mean? are dimensions of velocity. If I write velocity inside square brackets, what does it mean? Dimensions of velocity. Dimensions of velocity. Got it? Right. Velocity equals displacement over time. Please don't write. Velocity equals displacement over time. Therefore, dimensions of velocity equals displacement. Dimensions of displacement divided by dimensions of time taken. Please don't write anything. Velocity equal displacement over time. Therefore, dimensions of velocity equals dimensions of displacement divided by dimensions of time. Displacement is the shortest distance. Distance is the length of a path. Therefore, displacement is some kind of a length. Am I right, dear? Displacement is some kind of length. Therefore, dimensions of displacement capital L. Capital L. Dimensions of time is capital T. T comes up. Then you get the equation L T to power minus 1. Okay, dear? Now don't write. What is our target? Don't forget the target, right? What's your target? To be an engineer or a doctor. That's why you are coming to classes. Target is changed to I am here to see her. You're right. What's your target, boys? To learn well, to get 3 passes, be a doctor, engineer, scientist, or maybe a very good teacher. But after a few weeks, what will happen? I am here to see her. You're right. Don't forget the target. What's the target there? Finding the fundamental units of physical quantities. Look at board here. What is L? L is the dimension of length. L is the dimension of length. What is the SI unit of length? Meter. Am I right? What is T? It is the dimensions of time. It is the dimensions of time. What is the SI unit of time? Seconds. T to power minus 1. Therefore, S to power minus 1. T to power minus 1. Therefore, S to power minus 1. Then we say, therefore, the SI fundamental SI fundamental unit velocity. SI fundamental unit of velocity is meter per second, ms minus 1. Why did I use the word fundamental? Because length is a fundamental physical quantity. Do you remember the 7 fundamental physical quantities? Do you remember the 7 fundamental physical quantities? Yes, length is a fundamental physical quantity. Therefore, meter is a fundamental unit. Time is a fundamental physical quantity. Therefore, seconds is a fundamental unit. So, I have given the unit of velocity with fundamental units, right? For velocity, there is no big difference, but other cases, there will be huge differences. Something like universal gravitation constant, the units will be completely different. So, this is how to find fundamental unit of physical quantity by using dimensions. There are some other uses, some other applications of dimensions. This is the first one. Complete, write them all. right? You will understand this method after I discuss some examples. Normally, I will discuss about 20 to 25 examples. Uh, they will definitely ask in your term test. And even in A levels, as the first MCQ. There are 50 MCQs. The first one is this. Okay. Second example, look at board. Acceleration. Acceleration. What is acceleration, dear? Now you know it. Don't write. Velocity, increase in velocity divided by time taken. Look at board, dear. I have written acceleration inside the square brackets. What does it mean? When I write acceleration inside square brackets, the meaning is dimensions of acceleration. Acceleration equal velocity over time taken. Therefore, dimensions of acceleration equals dimensions of velocity divided by dimensions of time taken. Dimensions of velocity. Dimensions of velocity. What's it, dear? Dimensions of velocity is LT to power minus 1. Dimensions of velocity is LT to power minus 1. Divided by dimensions of time is, Lamai, dimensions of time is capital T. Capital T can be taken up. LT to power minus 1. When a denominator term comes up, it should come with a minus sign. So this T comes up with a minus sign, minus 1. T minus 1 into T minus 1. Can T minus 1 and T minus 1 is T minus 2. Therefore, dimensions of acceleration LT to power minus 2. Wait. What is L, dear? L is the dimension of length. Am I right, dear? Dimensions of length is capital L. SI unit of length, Lamai? Meter. Am I right? What is T? What is capital T, dear? Dimensions of time. What is the SI unit of time? Seconds. SI unit of time? Seconds. T to power minus 2. Therefore, we should write S to power minus 2. This is the method. There are no logical reasons. This is the method. If we have power with T, we write the same power with the SI unit. Am I right, dear? Dimensions of time is T. SI unit of time is seconds. As there is the power of minus 2 with T, we write the same power with S. T to power minus 2, S to power minus 2. Is it clear here? Then I should write here, but as I don't have space to write here, let me write here. Therefore, what is the SI fundamental? SI fundamental unit of acceleration. Lamai, SI fundamental unit of acceleration is ms minus 2. Got it? Complete. Write them all. Okay, right. Shall we try another example? Number 3. What is the meaning when I write force inside the square brackets, dear? When I write force inside the square brackets, what does it mean? Again, dimensions of force. Force is equal to F equals ma. Therefore, force is equal to the product mass into acceleration. Therefore, dimensions of force is equal to dimensions of mass into dimensions of acceleration. Can you do the rest without my help, dear? Right? Dimensions of force equals dimensions of mass into dimensions of acceleration. Dimensions of acceleration. Try to do the rest without my help, dear. Okay, right. Dimensions of mass, capital M. Dimensions of acceleration, dimensions of acceleration, LT to power minus 2. Dimensions of acceleration, LT to power minus 2. LT to power minus 2. Who got this answer? Right. Now let's do the same thing. Who found fundamental units also by using this? Others also try. Try to find fundamental units of force by using this. Have you found? Wow. What's it? Very good, very good. Mass is the dimension. Sorry. M is the capital M is the dimensions of mass. SI unit of mass is kilogram. Simple key है. Kilo के लिए meaning की है. Capital M is the dimensions of mass. Unit of mass, kilogram. Then L. L is the dimension of length. L is the dimension of length. SI unit of length is meter. T is the dimensions of time. T is the dimensions of time. SI unit of time, seconds. T to minus 2. Enang S to power minus 2. Who has written exactly like this? Lihat. Please write like this. This is a method. Actually, no logical reasons. This is a method that can be used to find fundamental units of a physical quantity. Okay, dear? It's a method. Right, now we can write, therefore, the SI unit, SI unit name, SI fundamental unit, SI fundamental unit, force, SI fundamental unit of force is kgms minus 2. kgms minus 2. Who has obtained this answer? Right. Clear? Very good. We came to this story Just after I taught you universal gravitation constant, am I right? We came to this case. What case? Fundamental unit case. We came to fundamental unit case after I told you about universal gravitation constant. Look at board dear. අපිට මෙහෙ පෙන්න. ළමයි, do you remember this figure? What is this dear? When there are two masses in the universe, they are attracted by a force. That force is known as gravitation force or gravity. Gravitation attraction force between any two masses is given by this equation. Actually, Newton said it in this way. Newton said that the force will be bigger if M1 is bigger. The force will be smaller if M1 is smaller. How to say mathematically? How to say it mathematically? Gravitation force will be larger if M1 is larger. Gravitation force will be smaller if M1 is smaller. How to say this mathematically? Directly proportional. Sadden kiyanne it is said as gravitation force directly proportional to the masses. It means F will be larger if M2 is larger. F will be smaller if M2 is smaller. Who found this result for the first time in the world? Newton. Therefore, these results said to be Newton's law of gravity. Whose law of gravity? Newton's law of gravity. And he found that force will be very small if the distance between the masses very large. The force will be very small if the distance between the force, if the distance between the masses very large. How to say it, dear? F proportional to 1 over r square. It means if r is larger, force is smaller. If r is smaller, force is larger. This is said to be, when you write something 1 over, it is said to be inversely proportional. It is said to be inversely proportional. Got it? So this result is known as Newton's law of gravity, because some students wants to know what Newton's law of gravity. So I told it now, right? Now these three things can be combined together. These three things can be combined together and write F proportional to M1, F proportional to M2, F inversely proportional to R square, or F proportional to 1 over R square. Now tell me how to convert directly proportional into an equation mark. Directly proportional into an equation mark. How do we do such a conversion? Multiply by a constant. To convert directly proportional into an equation mark, multiply by a constant. The constant is capital G. So capital G into M1, M2 into 1 over R square. This can be written as F equals G M1 M2 over R square. Whose law is this, dear? Newton's law of gravity. Saying example number 4, please write the heading universal gravitation constant within brackets capital G. Draw the figure and write down everything. No need to write this part. We have already written this part. Don't write this part. Write all the other things. Don't write the things inside the red color circle or red color shape. All the other things, draw the diagram and write the things and obtain Newton's law of gravity equation. right here. Now, subject capital G, dear. Subject capital G. So this is how to find the attraction force between any two masses in the universe. Subject capital G from this. Let's write the equation like this. Sorry, G M1 M2 over R square equals F. Write the equation like this. Take R square and M1 M2 to the other side. Take R square M1 M2 to the other sides. So you can subject capital G as R square into F divided by M1 into M2 divided by M1 into M2. Subject like this. Right. What is our target? Don't forget the target, right? Don't forget the aim. What is our target? Finding fundamental capital G. What is our target? Finding the fundamental unit of capital G. Look at board there. We have found that capital G equals R square F into R square F over M1, M2. So I can write like this. Therefore, the dimensions of, I can write like this. Therefore, the dimensions of capital G equals dimensions of R square, dimensions of force divided by dimensions of M1 into dimensions of M2. Please don't write, Lamai. Don't write when I explain. Please don't write. M2. Dimensions of R is a distance. Distance is a length. R is a distance. Distance is a length. Therefore, dimensions of R is L, but we have a square term. Got it? Into dimensions of force. Check the book and tell me. Dimensions of force. We have found it. Dimensions of force. ml high ml ml2 minus 2 divided by m1 mass of the first object. Mass is dimensions of mass is capital M. M2, it's a mass of the second object. It is also dimensions of M2 is also M. Write them all. M1 and M2 are masses, therefore their dimensions are capital M and capital M. M1 and M2 are masses, therefore their dimensions are capital M and capital M. Right. Then what will happen? Now you should clearly identify that this M and this M cancelled out. So what are the remaining terms, dear? Therefore, dimensions of capital G equals L square will be there into L t to power minus 2 divided by 1m term will be there. You see, stop writing. This m and this m cancelled out. This m will remain. So, like this. Am I right? Now, please don't write. L square into L. L square into L. සද්දෙන් කතා කරන්නකො ළමයි. L square into L. L cube. L cube. T minus 2 divided by M. Denominator M comes up as with the minus sign. So it will be denominator M comes with the minus sign. M minus 1, L to power 3. ගත්තයි. එකෙත් දෙන්නෙක් ඉන්නවා. හරි. ලියාගන්න. Target, find the fundamental unit of universal gravitation constant. What is our target? Finding the fundamental SI unit of universal gravitation constant. Capital M is the dimension of mass. Mass. SI unit of mass is kilogram. M to power minus 1, therefore we write a minus 1 power to kilogram. Listen to me. This is a method. Don't ask why. No answer for why. This is a method. One power for kilogram. Whatever the power with M, we write the same power with kilogram. Got it? Then L is the dimensions of length. L is the dimensions of length. What is the SI unit of length here? Meter. Whatever the power with L, we write that power with M. L to power 3, therefore we write M to power 3. What is here? Capital T is the dimensions of time. What is the SI unit of time there? Seconds. Don't write T is the dimensions of time. SI unit of time is seconds. Whatever the power with capital T, we write that power with S. Capital T is the dimensions of time. SI unit of time is seconds. Whatever the power with T, we write the same power with S. T to power minus 2, S to power minus 2. Now we have reached to our target. Therefore, the SI fundamental unit, SI fundamental unit of capital G, SI fundamental unit of capital G is kilogram to power minus 1 cubic meter S to power minus 2. The SI fundamental unit of capital G is kg minus 1 m3 s minus 2 per kilogram cubic meter per square seconds. How to read it there? Per kilogram cubic meter s minus per square seconds. But what is the unit that we have found earlier? Earlier we have found the SI unit of capital G is SI unit of capital G is Newton square meter per square kilogram. This is not fundamental because Newton is not a fundamental unit. Am I right here? Here all are fundamental. Kilogram, it is the unit of mass. Mass is a fundamental physical quantity. Therefore, kilogram is a fundamental unit. Meter, it is the unit of length. Length is a fundamental physical quantity. Therefore, meter is a fundamental unit. Seconds, it is the SI unit of time. Time is a fundamental physical quantity. Therefore, seconds is a fundamental unit. So, we have found the unit of capital G with fundamental units. Therefore, this is called the SI fundamental unit of capital G is per kilogram cubic meter per square seconds. So, this is the answer given in the exam. They will ask what is the SI unit of universal gravitation constant. What is the SI unit of universal gravitation constant here? Per kilogram cubic meter per square seconds. Or you can use Newton per square meter per square kilogram. What is the unit that we should use for capital G? We know 2. What is the unit that we use for capital G? Whatever the unit that you like. You have to, you can use whatever the one you like, right? Write them all, quick. Write them all. Is everything clear? Now we know how to find units in a simple method. According to the simplest method, Newton square meter per square kilogram. According to the method of dimensions, what is the unit of universal gravitational constant? Per kilogram cubic meter per square seconds. Got it? You should know both. Which one is the correct unit? Both are correct. Okay? Now listen to me, dear. Who has Netflix connection at home? තිබ්බනම් හොඳයි. If you have Netflix connection, or even in YouTube, I don't know whether it is available, watch this movie. It's a TV series. What is it, dear? Three-body problem. It's a sci-fi TV series. Sci-fi means science fiction. The thing is, Newton's law of gravity cannot be applied to find forces when there are three or more objects. Who has heard it? Newton's law of gravity. He said gravitation attraction force between any two masses. If there are three masses, what will happen? In this TV series, they are talking about, this is a very science students there should learn science, that because you love it. Don't learn science, I'll be a doctor, I'll do a private channeling, I'll learn millions of money. Can you understand here? Don't be money minded. You should learn science, that's because you love science. It's passion. Your passion is science. So there are three stars, right? The planet is moving along a path combined with due to the gravity of the three stars. A planet is moving due to the gravity of three stars. Then path followed by the planet cannot be calculated. Why? You cannot apply Newton's law of gravity when there are three or more objects with the planet. How many objects now? 4. Earth is a planet, Sun is a star. Do you know those things? So how many suns for this planet there? 3. So if you Colonite in Torrent download kala balu hai, right? It's a very good movie. This kind of movie, this kind of TV series, this kind of dramas will help you to develop your love on science. If you don't love something, if you don't like something, you can't learn it well. Got it? So if you have a free time, watch it. Right. Then, Alan, the other problem with Newton's law of gravity is, if a planet is very closer to a star, if a planet is very closer to a star, again you can't apply Newton's law. Who knows it? That's why I ask you to watch sci-fi movies and sci-fi dramas. You can find those things. Clear, dear? When you love someone, you can do sacrifices for it. Am I right? තාත්තගෙන් අහන්නකෝ. ගෙදර ගිහිල්ලා තාත්තෙන් අහන්නකෝ. When you love someone, you can do sacrifices. අපේ තාත්තා මාත් එක්ක කියලා තියෙනවා. අපේ තාත්තා කිරිතේ බොන්නේ. මං එහා වෙයි කියලා. අවුරුදු 5ක් මං හම්බෙනකන් අපේ අම්මා හදපු කිරිතේ තාත්තා බිව්වලු. Huge sacrifice. යකෝ අපේ අම්මා පවුලේ බාලේ අවුන්ද දන්නේ තේ තියා වතුරුණු කරන්නේ කොහොමද කියලා ඇමරිකල්ල යනකොට. But he can do such sacrifices. Why? That's because of his love. He always call Manike. Like that, if you love science, you can do sacrifices and you can learn it well. How to make an attraction, bond, affection, passion with science. Watch some sci-fi drama, sci-fi series. Let's come back to the case. If a planet is very closer to a star, you cannot apply Newton's law of gravity. For example, what is the nearest planet to the sun? Mercury. Nearest planet to the sun is Mercury. After that, who is Venus? The most beautiful goddess, ne? After Venus, api, Earth. Earth. After the Earth, Mars. After Mars, Jupiter. After that, Saturn. After that, Neptune. Pluto is not in the family now, right? Now that's a huge problem with Mars. Mercury, when we apply Newton's law of gravity, we can't calculate and find the correct path followed by the Mercury. Who has heard it earlier? If you want to find the correct path, if you want to calculate the correct path followed by Mercury, you should use Einstein's equations. Whose equations, dear? Einstein's equations. So if you want to learn Einstein's equation, go to University of Colombo, learn physics as a subject. That's what I did. Because I wanted to know how to find the paths of planet. The other thing, again, how many planets are there? 3. When there are 3 planets, there will be attraction forces between the planets. In addition, the sun is there. Again, to calculate paths of 3-body problem. With the sun, again, you have to use Einstein's equation. Okay, dear? Newton's law of gravity is okay for some calculations, but not all the gravitation calculations. Can you understand here? Newton's law of gravity can be used for some calculations. What is the universal method for gravity here? Universal equations for gravity. It means what are the equations that can be used anywhere? Einstein's equation. Okay, dear? So when you go university, learn physics as a subject, learn Einstein's equations. Okay, dear? හරිද? ඔහොම බලන්න එපා මන් දිහා බයි දෙනවනේ. මං ගේට් බොයිස් එකකට ඕගොල්ලෝ කොහොමද බලන් ඉදි කොහොමද කියන්නේ ඔයගොල්ලන්ගේ? එච්චර ලොකු දෙයක් මං කිව්වද? Simple part, right? Not a perennial theory. ඊළඟ කැලලත් කියලා නවත්තන්න. To learn Einstein's equations, you need a sound knowledge of calculus, maths. Therefore, learn maths from the best teacher. We have the best teacher with us. Please go to Anand Ilankon's class. I'm telling you this because maths has 2 papers. How many maths students are here, physical science students? What are the 2 papers? Pure maths and applied maths. Pure maths, applied maths, අපේ ආනන්ද සර්ට විතරයි පුළුවන්. ඒකයි වැඩේ. Pure maths can be learned within the first year. Second year, real maths started. Applied maths. So therefore, and especially trigonometry. So learn trigonometry, calculus very well. So please join this class. It's not please. Why should I say please? You are not my friends. You are not my brothers and sisters. If you want to have A for maths, you should join. Right? Right. How many of you joined Sampasa's class team? So he's the best bio master. The other thing is, dear, when I arrange my tutorial discussion class, when I arrange my paper class, I discuss only with Anand sir, Sampath sir, and Vajira sir. And then I decide my date and time. මට පුළුවන් මේ නුවර වටේ ගිහිල්ලා හැම එකාගෙන් මාණ්ඩු වාගේ ෆිසික්ස් පන්තියේ කොහෙද කී වෙලාවද වාගේ බයෝ එක කොහෙද වාගේ කෙමිස්ට්‍රි එක කොහෙද මට මේ පේපර් ක්ලාස් එකක් දානවා දැන් මට ටවුන් එක වටේ ඇවිත් හැකිද උන් හිතයි මට පිස්සු කියලා. ඒතර මම මොකද කරන්නේ? නෑ ප්‍රැක්ටිකලි බලන්නකො ළමයි. මට පේපර් ක්ලාස් එකක් දාන්න ඕන. මට ටියුටෝරියල් ඩිස්කෂන් එකක් දාන්න ඕන. සහ මේ අවුරුද්දේ දානවා මෙන්න මේ ක්ලාස් එක. මොකද්ද? Merit list එක වැඩි කිරීමේ class එක. How to increase the merit list. Merit class is started. When we increase the merit list, we can increase the number of students selected engineering and medicine. ඒ කියන්නේ සාමාන්‍ය ළමයෙක්ට කැම්පස් යන්න පුළුවන් අති දක්ෂව merit list එක හරහා engineering medicine යවුවොත්. දැන් මට ක්ලාස් කීයක් දාන්න ඕනද? 3යි. මොනවාද? paper class, tutorial class and merit class. With whom I discuss to manage to decide my date and time? Only with the teachers at IMS. Can I discuss with other teachers at other institutions? No. Therefore, it's very important join to the teachers at IMS. The other thing is අනේ බං උඹලට ප්‍රොපෙක් ගෙන් ඉගෙන ගන්න හම්බෙන එකම තැන මේකනේ. නැද්ද? කෙමිස්ට්‍රි ඉගෙන ගන්න යුනිවර්සිටි ලෙක්චර් කෙනෙක්ගෙන් කෙමිස්ට්‍රි ඉගෙන ගන්න හම්බෙනවද? මටවත් හම්බෙලා නැහැ යකෝ. මේ ඉගෙන ගත්තා නම් මටත් කෙමිස්ට්‍රි වලට ඒකක් එන්නේ. ඔව්. මට කෙමිස්ට්‍රි බැරිකම නෙවෙයි හොඳ. මට කෙමිස්ට්‍රි බැරිකම නෙවෙයි. මාත් කැම්පස් ලෙක්චර් කෙනෙක්ගෙන් ඉගෙන ගත්තා නම් වෛද්‍ය සේවය වගේ මට කෙනෙක්. එහෙම නෙවෙයි ළමයි මට නම් බෑ. බොරු කියන්නේ මොකද කෙමිස්ට්‍රි හරි අමාරුයි මට. Right. Yeah, so bio class will be started in the same hall. Maths class is at hall number 25. ගිය සතියේ maths class එකට ගියා චුට්ටක් දවසක්. අයගොල්ලෝ පොඩ්ඩක් අලුත් අය class room number 25 පෙන්නන්න. ළමයි wait one more thing. What is the thing we learned today? What's the thing we learned today? How to find fundamental limits of a physical quantity by using dimensions. Lavai, there's a small problem. You know that from April 18 to April 28, there is some kind of thing in Kandy, Dalda Maligawa. Sometimes police will ask to stop the classes. Therefore, please send me a WhatsApp message to this number. Then I will inform whether we are doing the class next Friday or not. Can you understand here? Everybody, please write my WhatsApp number. Send me a WhatsApp message. ඔයා හිතන්නකෝ දැන් මේ අද උදේ තිබ්බ ෆන්ක්ෂන් එකට ඔච්චර රෝප් මේ පාර බ්ලොක් වෙනවා නම් දයදා මාලිගාව දවසට ලක්ෂ 6ක් ආවම පාර කොහොම බ්ලොක් වෙයිද? So everybody please send me a WhatsApp message. Then I will tell you whether we are doing the class next week or not. Send me a WhatsApp message. I am a 27 student and IMS. Then I will inform whether we are doing the Friday class. ළමයි අපි මේක මේ online කරාට කමක් නැද්ද next Friday class එක? බැරි වෙලාවත් පාරවල් ඇහුවොත්. Is it okay if I do next Friday class online? Is it okay? Please tell me whether if the roads are blocked, if roads were closed due to that thing, right? Send me a message whether you are okay to do next Friday class online, right? Okay, see you. Please see you all. Good luck. We will meet after the new year. Right, see you. Bye. Take care. Good luck.